In the present video, we are going to see the functioning of the equipment of integral control of pressing, LaserMeter. The final quality of the tiles depends to a great extent on the process of pressing, which will shape the tile in his suitable dimensions and without dimensional faults. To have a correct pressing, it is necessary to realize quality controls on diverse parameters that concern the final result. Traditionally, there is controlled the density or hardness of the material newly pressed. That will reverberate later in the contraction during the boiling. It is controlled, so much the average value of every exit of press, that would give place to variation of calipers, as his superficial distribution, that would give place to dimensional faults, lenses, taper, etc. Also a control of thicknesses is realized, measuring in the most significant zones of the tile, and checking that does not exist variation, that would influence, between others, to the packaging process. Finally, there realizes a control of weight, or load of clay, that as the variations of density or hardness, also would reverberate in calipers and deformations during the boiling. The equipment LaserMeter uses technology of telemetry laser, which allows him to control the totality of mentioned parameters, both in his average values and in his superficial distribution. Supposing a great advance opposite to the traditional methods, which were not allowing such an exhaustive control of every parameter. To make the measurement, we take each green tile and we cut it in files and columns in a representative number of pieces. We put in order those pieces and insert them in the pieces distributor. We select the press and pressing plate numbers and press the start button. At the end of the measurement, the results obtained in each test are stored in a historic and can be collected and analyzed at will. As an example, we will recover and analyze several essays from the historic, flawed representative of difficult detection with traditional methods. First, we end the historical. We cancel that previous selection, and select the test of the tile that we want to recover. We can identifying the date of accomplishment of the test, the hour, the number of press, the number of exit or plate, and the model who was pressed. Once selected, we validate pulsating OK. The first thing that we are on having gathered the information, they are the slogans of work with which the tile was pressed. We can observe the slogan of density, with its range of work. The slogan of load of clay, with its corresponding range. The slogan of thicknesses, with its corresponding range. And in the left side, we can observe a scale of color, with the central white zone, that it represents that the information is inside the range of work. A zone with several tones of blue, that indicates that the value exceeds the range of the slogan. And a zone of red tones, that indicates us that the value does not reach the zone of slogan. This color range uses so much at the back of the numerical values, since in the graphical representations, to identify rapidly any diversion of the parameters with regard to slogan, both for fault and for excess. To analyze the data, in group mode, the first thing that we will verify the average values obtained in the test. We have from left side to right, average density, average loads of clay, and average thickness. We see that the data box is divided into boxes. Each one of them represents one of the pieces in which divided the tile. In every box we have a numerical value, at the top, indicating the value of density. In the central area, the value of load of clay. And, in the lower area, the thickness value. Each one of them with a color background, depending on the scale described above. Data are grouped to be able to quickly see that there is no red or blue zones, and if any, indicating little deviation. For greater clarity, we can observe the data separately, simply by clicking on the checkbox corresponding motto, for example, in densities. In this case, we see that, while the bottom row has a little less than densities. All the data are in the working area, and therefore we should not have problems at the exit of the oven. If we click again on densities, we will see the average values. On the sides, the corresponding to each area, and in the center, the average total value. And if we click density again, we would see the graphical representation of distributions. If we now repeat individual visualization, in clay charge parameter, we have a problem. We have a central area which is good, but we have a bottom row with funds in red, and a top with blue funds. And, when we have red and blue at the same time in a tile, indicates a more than possible problem. In this case, if you look at the numbers, we can see that the bottom row is approximately 100 thousandths lower than the top row. This tells us that truck has left less land ahead than behind. In a conventional equipment, we only would have the value of densities, which says to us that everything is okay. Because the bit has been pressed by isostatic punches, and the oil to distributed the pressure, equalizing the densities. This equalization carries a variation in the thicknesses, which is minimized if there are used plates of constant rib, also called of grid. In this case, scarcely they appreciate 2/10 of difference between the low and top rows, since the variation of thickness is concerned in the face of the rib, between the supports. If we were attending only to the traditional methods, both the densities and the thicknesses indicate us that everything will be okay. But in the practice, when the difference of load of clay is so big, the zone with minor quantity of material contracts more in his step along the oven, whereas the zone with more material contracts less. This reverberates in a taper deformation that the traditional methods were not indicating, and that alone it appreciates with the distribution of load of clay. Continuing with another example, we can estimate the versatility of the historical one, which allows us, for example, gather at the same time another test of another press in which we are producing the same model. Of this form we will be able to verify that both were working. In this case, in the production of the press 3, we estimate a different effect. The low and top rows have similar load of clay, but much higher than the middle row. If we observe it in graphical way, we estimate that while the press 2 will have a problem of cone, the press 3 will have a problem of lenses. The equipment is so versatile, that even allows to stamp united the results of these two tests. If we are in numerical representation, the result will be like the following one, where we can see the identifications of every press, the values of every test, beginning for the average total density, the average lateral densities, and the density of every pieces, and the same thing for the loads of clay and the thicknesses. The printing format can be selected between 3 different types from report, according to needs or predilection of the client. We can choose for an impression group to use less ink. We can choose for a grouped impression, adding boxes of deviation with regard to average density, like that as boxes to annotate the dimensions of exit of oven. And we can choose for the distributed impression that already we have seen. For major clarity, if we were in graphical way, the icon of the printer is different, and the impression would be similar to the following one. Here we see the graphical distribution of densities of every plate, the graphical distribution of loads of clay, and finally, the graphical distribution of, and all this, only in what refers to traditional glazed tiles. When we speak of porcelain tiles, usually large and which also have to polish, the importance of uniformity in thickness is of maximum importance, since it depends on spending on polishing machines, and since the variation in the thickness directly depends on the distribution of load of clay, it is essential to have this parameter that cannot choose by traditional methods of control. In this example we see a 60 by 120 tile, in which we appreciate variation of thickness in some areas. According to the distribution of load of clay, we can deduce that material has moved to the site during pressing, producing areas with lower thickness, or one side with greater thickness. According to the numerical values, we appreciate that the difference between one side and the other, round 4/10, and the two-prop, we have a difference between the minimum and the maximum, of almost 7/10. The cost in polishing would be great. If the material was a gloss, or partial polishing, it would be virtually impossible. The LaserMeter is not only the unique control equipment capable of detecting these errors that will result in defects and costs. It is also the only one able to synchronize at the same time with teams of correction load compenser, creating and transmitting the tables of load compensation. To do this, the load compenser has a series of servo actuators with built-in microcomputer. Equipment LaserMeter generates the correction tables for each servo actuator load compenser. In this example, we can observe the graph of each actuator with respect to the neutral line correction. During the retreat of the truck, each actuator will move according to his graph. By adding more or less load of clay in the area requiring it, and even removing some of the material in the remaining areas, the combination of the two resulted in the total elimination of dimensional and surface defects, which to date were very difficult or impossible to correct. For more information, see our website www.lvsl.s.